current transformer or CT cabinet houses the current transformers, or CTs, that are used to measure the electrical current flowing through a circuit. CT are typically used in conjunction with meters or other devices to monitor or control the electrical system. A CT cabinet is generally required when the electrical current in the circuit exceeds the maximum current rating of the measuring device. In other words, if the current is too high to be directly measured by the meter or other device, a CT is used to reduce the current to a manageable level. The use of CT cabinets is typically governed by electrical codes and standards. Some relevant codes and specifications include firstly the National Electrical Code or NEC, specifically chapters 450 and 480. Secondly, the Institute of Electrical and Electronics Engineers or IEE standards, specifically IEE STD 10.2004, which covers symbols for electrical quantities. Thirdly, manufacturer specifications. Specific requirements for the CT cabinet and CTUs may vary depending on the manufacturer. NEC Article 450.43 requires that CT cabinets meet the following requirements: 1. Be made of metal or other approved material resistant to corrosion. 2. Have a door or cover that can be locked or sealed. 3. Be located in a clean and dry environment. 4. Be large enough to accommodate the CT and associated wiring. 5. Have a ground connection. In the specific case where there is a 600 amp service, that level of current may be too high for the metering device to measure directly. The CT cabinet will house the CT that will reduce the current to a level that can be measured by the meter. It is important to consult with the manufacturer of the CT and the electrical code requirements to determine the specific requirements for the CT cabinet and CT in that particular application. A current transformer, or CT, is a type of instrument transformer that is designed to accurately measure high alternating current, or AC, currents. It produces a reduced current in its secondary winding, which is proportional to the current in its primary winding. This allows the current to be safely and easily measured by a metering device. Here's a more in-depth look. Current transformers are used to step down high current to a low value that can be safely measured by ammeters and other instruments. The primary winding of the CT is connected in series with the conductor carrying the current to be measured. The secondary winding is connected to an ammeter or other measuring device. The ratio of the primary current to the secondary current is known as the CT ratio. For example, a CT with a ratio of 600.5 would produce a secondary current of 5 amps when the primary current is 600 amps. CT are designed to operate with a specific burden, which is the impedance of the metering circuit connected to the secondary winding. The burden is typically expressed in volt-amps or VA. It is important to select a CT with a burden rating that is appropriate for the metering circuit. CT are used in a variety of applications, including power metering, protective relaying, and current monitoring. They are commonly found in substations, power plants, and industrial facilities. The NEC provides guidelines for the installation and use of CT, including requirements for wiring, grounding, and protection. These requirements are intended to ensure the safe and reliable operation of the electrical system. When selecting a CT, it is important to consider the following factors. Firstly, the primary current range. Secondly, the CT ratio. Thirdly, the burden rating. Fourthly, the accuracy class. Fifthly, the insulation voltage. And sixthly, the physical size and mounting requirements. Current transformers are essential components in many electrical systems, allowing for the safe and accurate measurement of high currents. Understanding the operating principles and application requirements is crucial for electrical engineers and technicians. The National Electrical Code, or NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years to reflect changes in technology and industry best practices. Article 450 of the NEC covers transformers, including current transformers. This article provides requirements for the installation, grounding, and protection of transformers to ensure safety and prevent electrical hazards. Article 450.43 specifically addresses the requirements for current transformer or CT installation. Some key requirements outlined in this section include: firstly, CT must be installed in a safe and accessible location. Secondly, CT must be securely mounted to prevent movement or vibration. Thirdly, CT must be protected from physical damage. Fourthly, CT must be properly grounded to prevent electrical shock hazards. Fifthly, CT secondary circuits must be protected from overcurrent. The NEC also provides requirements for the wiring of CT secondary circuits. These requirements are intended to prevent excessive voltage drop and ensure accurate metering. In addition to Article 450, other articles in the NEC may also be relevant to CT installations depending on the specific application. For example, Article 250 covers grounding and bonding requirements, which are essential for ensuring the safety of electrical systems. Article 310 covers conductor requirements, including ampacity and insulation. It is important to consult the NEC and other relevant standards when installing CT to ensure compliance and prevent electrical hazards. Understanding the NEC requirements for CT installations is crucial for electrical engineers, contractors, and inspectors. By following these guidelines, it is possible to ensure the safe and reliable operation of electrical systems. The Institute of Electrical and Electronics Engineers, or IEE, is a professional organization that develops standards for a wide range of electrical and electronic technologies. IEE STD 10.2004 is a standard that provides symbols for electrical quantities, including those used in power systems and instrumentation. This standard is widely used by electrical engineers and technicians to ensure consistent and accurate communication of electrical concepts. The standard covers a wide range of electrical quantities, including voltage, current, power, impedance, and frequency. It provides both letter symbols and graphical symbols for each quantity. The letter symbols are used in equations and formulas, while the graphical symbols are used in circuit diagrams and schematics. IEE STD 10.2004 is an important reference for anyone working with electrical systems. It helps to ensure that electrical quantities are represented consistently and accurately, which is essential for effective communication and problem solving. The standard is updated periodically to reflect changes in technology and industry best practices. In addition to IEE STD 10.2004, the IEE also publishes many other standards that are relevant to electrical engineering. These standards cover a wide range of topics, including power systems, instrumentation, communications, and computer engineering. The IEE is a leading source of technical information and standards for the electrical and electronics industries. Its standards are widely used by engineers, technicians, and researchers around the world. Understanding IEE standards is crucial for anyone working in these fields. By following these standards, it is possible to ensure the quality, reliability, and safety of electrical and electronic systems. When selecting a current transformer or CT cabinet, it is important to consider the manufacturer's specifications. These specifications provide detailed information about the performance characteristics, installation requirements, and safety features of the equipment. The manufacturer's specifications typically include the following information. Firstly, the CT ratio, which is the ratio of the primary current to the secondary current. Secondly, the burden rating, which is the impedance of the metering circuit connected to the secondary winding. Thirdly, the accuracy class, which indicates the accuracy of the CT over a specified range of currents. Fourthly, the insulation voltage, which is the maximum voltage that the CT can withstand without insulation breakdown. Fifthly, the operating temperature range, which is the range of temperatures within which the CT will operate reliably. Sixthly, the dimensions and mounting requirements, which specify the physical size and how the CT should be mounted. Seventhly, the wiring diagrams, which show how to connect the CT to the metering circuit. It is important to carefully review the manufacturer's specifications before selecting a CT or CT cabinet. This will help to ensure that the equipment is suitable for the specific application and will operate safely and reliably. The manufacturer's specifications may also include information about the applicable standards and certifications, such as those from the NEC, IEE, and all. These certifications indicate that the equipment has been tested and meets certain safety and performance requirements. In addition to the manufacturer's specifications, it is also important to consider the overall system requirements when selecting a CT or CT cabinet. This includes the primary current range, the required accuracy, and the environmental conditions. By carefully considering all of these factors, it is possible to select the right equipment for the job and ensure the safe and reliable operation of the electrical system. When dealing with a contractor's request for a current transformer or CT cabinet, it is important to carefully evaluate the reasons behind the request. A CT cabinet is typically required when the electrical current in the circuit exceeds the maximum current rating of the metering device. However, there may be other reasons why a contractor might request a CT cabinet, such as to improve the accuracy of metering or to provide additional protection for the metering equipment. To evaluate the contractor's request, it is important to gather information about the following: firstly, the primary current range; secondly, the CT ratio; thirdly, the burden rating; fourthly, the accuracy class; fifthly, the insulation voltage; sixthly, the operating temperature range; seventhly, the dimensions and mounting requirements; eighthly, the wiring diagrams. Once you have gathered this information, you can compare it to the manufacturer's specifications for the metering equipment and the electrical code requirements. This will help you to determine whether a CT cabinet is actually necessary. If a CT cabinet is required, it is important to select one that is appropriate for the specific application. This includes considering the size of the CT, the wiring requirements, and the environmental conditions. It is also important to ensure that the CT cabinet meets all applicable safety standards. If you are unsure whether a CT cabinet is required or which one to select, it is best to consult with a qualified electrical engineer. An electrical engineer can help you to evaluate the contractor's request, select the right equipment, and ensure that the installation meets all applicable safety standards. Remember to prioritize safety and compliance with electrical codes when dealing with high amperage services. Current transformers, or CTs, play a crucial role in electrical power systems by enabling the safe and accurate measurement of high currents. To fully appreciate their function, it's helpful to understand how they work internally. A CT is essentially a type of instrument transformer designed to produce a secondary current that is accurately proportional to the current flowing in its primary winding. This scaled-down current can then be measured by ammeters, protective relays, and other metering devices. At its core, a CT consists of a core, a primary winding, and a secondary winding. The core is typically made of laminated silicon steel, which provides a low reluctance path for the magnetic flux. The primary winding is the conductor carrying the current to be measured. It can be a single turn or a few turns of heavy gauge wire, depending on the current rating. The secondary winding is a multi-turn winding of smaller gauge wire that is electrically isolated from the primary winding. When current flows through the primary winding, it creates a magnetic flux in the core. This flux induces a current in the secondary winding. The ratio of the primary current to the secondary current is determined by the turns ratio of the transformer. For example, if a CT has a turns ratio of 100:1, then a primary current of 100 amps will produce a secondary current of 1 amp. The accuracy of a CT is determined by several factors, including the quality of the core material, the accuracy of the turns ratio, and the burden impedance connected to the secondary winding. The burden impedance is the total impedance of the metering circuit connected to the secondary winding. It includes the impedance of the ammeter, the connecting leads, and any other devices in the circuit. It's essential to select a CT with a burden rating that is appropriate for the metering circuit. If the burden impedance is too high, it can reduce the accuracy of the CT. If the burden impedance is too low, it can cause the CT to overheat. CT are designed to operate under specific conditions and are often categorized by their accuracy class. The accuracy class specifies the maximum area that the CT will exhibit over a specified range of currents. For example, a CT with an accuracy class of 0.5 will have an error of no more than 0.5%. Another important aspect of CT operation is the concept of saturation. Saturation occurs when the magnetic flux in the core reaches its maximum value. When a CT is saturated, it can no longer accurately reproduce the primary current in the secondary winding. Saturation can be caused by excessive primary current, excessive burden impedance, or a combination of both. To prevent saturation, it's important to select a CT with an appropriate current rating and burden rating. In summary, current transformers are precision devices that rely on fundamental electromagnetic principles to provide accurate current measurements in high-voltage power systems. Understanding their internal workings is key to ensuring proper selection, application, and performance. Current transformers are indispensable tools for monitoring and protecting electrical grids and industrial facilities. Without them, it would be impossible to safely and reliably measure the high currents that flow through these systems. Therefore, a good understanding of their operational principles is essential for anyone working in the field of electrical power engineering. The selection of appropriate current transformers or CT for a specific application is a critical step in ensuring accurate and reliable current measurement. Several factors must be carefully considered to make the right choice. Firstly, the primary current range. The CT must be able to accurately measure the full range of currents expected in the primary circuit. This includes both normal operating currents and fault currents. Secondly, the CT ratio, the ratio between the primary and secondary currents, should be chosen to provide a convenient and safe secondary current level for the metering or protection devices. Common secondary current ratings are 5 amps and 1 amp. Thirdly, the burden rating. The CT must be able to supply the required volt-amp burden of the connected devices without exceeding its accuracy class. The burden is the impedance of the secondary circuit, including the metering or protection devices and the connecting leads. Fourthly, the accuracy class. The required accuracy class depends on the application. Metering applications typically require higher accuracy than protection applications. Fifthly, the insulation voltage. The CT must be able to withstand the maximum voltage of the primary circuit. Sixthly, the frequency. The CT must be designed for the frequency of the power system. Seventhly, the size and mounting. The CT must be physically compatible with the installation location. In addition to these technical factors, it is also important to consider the cost and availability of the CT. It is also important to consult with the manufacturer's specifications and application guides to ensure that the CT are suitable for the specific application. Choosing the right CT is essential for ensuring the accurate and reliable operation of electrical power systems. Careful consideration of all the relevant factors will help to ensure that the CT meet the requirements of the application and provide accurate current measurements. Proper installation and maintenance of current transformers or CT are essential for ensuring their continued accuracy and reliability. Here are some key guidelines to follow during installation. Firstly, handle with care. CT are precision instruments and should be handled carefully to avoid damage. Secondly, inspect for damage before installation. Inspect the CT for any signs of damage, such as cracks, chips, or loose connections. Thirdly, mount securely. CT should be mounted securely to prevent vibration and movement. Fourthly, use proper wiring. Use the correct size and type of wire for the secondary connections. Fifthly, ground properly. The CT should be grounded properly to prevent electrical shock hazard. Sixthly, verify connections. Verify that all connections are tight and secure. Seventhly, test after installation. Test the CT after installation to verify their accuracy. Regular maintenance is also important for ensuring the continued accuracy and reliability of CT. Here are some key maintenance tasks. Firstly, inspect periodically. Inspect the CT periodically for any signs of damage, such as cracks, chips, or loose connections. Secondly, clean regularly. Clean the CT regularly to remove dust and dirt. Thirdly, test periodically. Test the CT periodically to verify their accuracy. Fourthly, replace if necessary. Replace the CT if they are damaged or not functioning properly. Following these guidelines will help to ensure that CT provide accurate and reliable current measurements for many years. Proper installation and maintenance are essential for maximizing the performance and lifespan of these critical components of electrical power systems. Neglecting these tasks can lead to inaccurate measurements, equipment damage, and even safety hazards. Therefore, it is important to prioritize proper installation and maintenance of CT to ensure the safe and reliable operation of electrical power systems.